All right, in this quick mini lesson, we're going to review how do we multiply rational expressions. And for that topic, we need to kind of remember how do we multiply fractions. And so most of you would probably remember that when you have a couple of fractions that we're multiplying together, we just multiply the numerator times the numerator and the denominator times the denominator. So if you look at this set of two fractions that are being multiplied together, we will end up with the expression a times b in the numerator and c times f in the denominator. Now you would always want to check and make sure there are no common factors in the numerator and the denominator that can divide out. In this next example, we have something a little more concrete. We have two fractions, two rational expressions actually, because we have some variables thrown in there as well. So there's a couple of different ways and methods to do this. I'm going to show you both, and I'm going to show you the advantages to both. So we can start this process just like we did before, and we can say that this is going to be 3x times 5, and that's all going to be divided by 7y times 6a. Now, if we multiply those expressions together, we would have ended up with 15x divided by 42ay. Now we would want to go ahead and see if there are any common factors here, and with the variables, there's nothing in common with the variables. So with the 15 and the 42, they both have a common factor of 3. So we would want to divide that out, and we would end up with 15x divided by 14ay. Now, that's a perfectly acceptable method of multiplying and simplifying these rational expressions. However, what if we simplify first and then multiply? Let's go back to our example. I'm looking at this example, and I'm looking at things in the numerator and the denominator. And I notice that I have a 3 in the numerator and a 6 in the denominator. Well, what does that mean? I have a 3/6 in the expression, which means I can actually simplify that and make this a 1 and this a 2, right? Because 3 divided by 6 is the same as 1 divided by 2. By simplifying first, it makes life just more simple, right? Because now I just multiply the 5 times the x, and I divide that by the 7 times 2 times a times y, or 14ay. So I personally believe that the earlier you can simplify, the better, but that is just a matter of preference. So in this next example, I notice that I have two rational expressions that are being multiplied together. And I'm going to want to see if I have any common factors when I do the multiplication. But I do see right away that I have a 2 and a 4 that can be simplified. Do you see that? That's going to help us. Let's go ahead and factor out what's left and see if there are any other common factors that we can divide out. So in the first rational expression, I have 3 times c minus d. And in the second rational expression, that's all multiplied by 1. All right, so that's our numerator when it's multiplied. In the first rational expression, I have a factor of 2. And in the second rational expression, I have a difference of squares pattern here with the c squared minus d squared. So that is going to factor into c plus d times c minus d. Now, when I look at what I've arrived at here, I do see some common factors. I see that in the numerator and the denominator, I have c minus d, so I can divide them out because that's equivalent to 1. And then I'm just going to express what's remaining as my final answer. So I end up with 3 divided by 2 times c plus d. And we can just leave it just like that. All right, in the last example here, I see a lot of factoring that's going to happen. So I'm going to dust off my factoring skills and put them to good use. I don't see anything that I can simplify right away, so I'm just going to start with the factoring. In the numerator of the first rational expression here, I've got m squared minus 4m plus 3. That is going to factor into m minus 3 times m minus 1. That negative 3 and that negative 1 multiply to make the positive 3 and add to make the negative 4. In the denominator of this first rational expression, I see common factors of 9 in that 9m plus 18. So we'll factor out that GCF of 9, and we will be left with m plus 2 when that one is factored out. Let's go to that second rational expression, and we have a quadratic there in the numerator. We're looking for two things that multiply to make negative 8 and add to make negative 2. That's going to be m minus 4 and m plus 2. That negative 4, positive 2, multiply to make negative 8, add to make negative 2. And then in the denominator there, we see a common factor of m. And so we can factor that out as a GCF, m times m minus 3. All right, so I have everything factored, and now I can go back and divide out everything that has a common factor in the numerator and the denominator. Notice that this m minus 3 divides with this m minus 3. This m minus 1 does not have anything that divides out in the denominator, nor does this m minus 4. But this m plus 2 definitely can divide with this m plus 2. And so now I'm left with these two things in the denominator. I would then just write my resulting rational expression. So I would have m minus 1 times m minus 4 in the numerator and 9m in the denominator. Our next topic will be dividing rational expressions with it, which is just an extension of multiplying rational expressions. See you then.